Good morning, year five. Today we have another voiceover lesson. It's going to be a science lesson, our first one on YouTube. This lesson is going to focus on changes in materials. Today we're going to be learning the two types of changes that can occur. You're going to be needing a notebook, a pencil, and if you have them, some crayons or color pencils. Let's get started. So first of all, let's look at the two types of changes. This poster that you're seeing right now shows that there are physical changes in materials as well as chemical changes. If you need to, go ahead and pause right now and have a read through it. What you're going to find is that physical changes can be reversed. That means when you change the material, it can go back to what it originally was. But if you look down, a chemical change cannot be reversed. So that means when you change it, it can't go back to what it was before. It's stuck in that new state. So a chemical change changes what's on the inside of that material so that it's no longer really the same thing. It's something new. So chemical changes create a new material, whereas physical changes maybe just change the state of the material or change how it looks, but it's still the same material. Let's zoom in on that a little bit more. So in this poster, we get a closer look at what chemical changes and physical changes are. It's done them backwards now, so try not to get confused. It's starting with chemical changes. So a chemical change means that matter becomes something different. It cannot go back to what it was before. So think of it as the chemicals inside of it, the things that make up the material, have changed. So it's a completely new material. Whereas a physical change on the other side of that T-chart, it says that matter looks different, but it is still the same thing. It can go back to what it was before. Let's take a look at the examples. So under chemical change, the examples of things that can't go back, for example, are like when you fry an egg. When you start, the egg is raw, it's runny, it's liquidy. But when you fry it, it becomes more solid. Can you unfry an egg? Can it go back to being a raw egg? No. The same thing with fireworks or fire. When you burn something, it can't go back to what it was before. You might have started with a piece of wood, but by the end, when you're done burning it, it's just a pile of ash. It's no longer wood. But when we look at the physical changes, things that can go back, perhaps crushing a piece of paper. It's still a piece of paper, it just looks a little bit different. The same thing with an ice cube. Ice is made up of water. If you melt an ice cube, it turns into liquid, but can you get it back to an ice cube? Yeah, you just freeze it. Same thing with a popsicle, the exact same thing actually. It's like you've just frozen something and then you can unfreeze it by melting it and then just change it right back. So physical changes can be reversed. It's just the look of it, the physical appearance that changes. Whereas a chemical change is something on the inside. You can't get it to go back to what it was before. Now let's take a look at some common physical changes. It says at the top of this poster, remember, during a physical change, although some properties like shape, phase, etc. of the material change, the material itself is the same as before and after the change. A physical change can be undone. That means it can be reversed. So here we see a piece of paper being cut. Even though it's been cut, it's still paper. Sure, we can't really get it back to the whole shape that it was before, but the material itself has not changed. The paper is still paper. It's just smaller pieces of paper. Same thing with the shredder. Then we have an example of boiling. That pot over at the right, we see the water at the top, it's being heated. Then it turns to gas, so the particles are moving more. But if you take the heat off, it's going to cool down and go back to being water instead of being steam. So again, that change can be undone. Melted butter is another example. When it's hot, it melts, but when you cool it back down, it goes right back to the state it was in before. So it's just changing its shape and its phase. That means the state of matter that it is. Same with crumpled up foil. And that last example is, it looks like somebody carving like a clay model. So they can just mush the clay back to what it originally was. All they've changed is the shape. Now, this poster takes a closer look at chemical changes. Notice that it calls it at the top irreversible changes. That means it cannot be changed back. Once it's done, it's done. It says, what is an irreversible change? An irreversible change is a permanent change that cannot be undone. For example, baking a cake. When you mix up the batter and then stick it in the oven, you get a cake. You can't do something and undo the baking process, it's going to stay a cake. You cannot turn it back to batter. The same thing with the egg, whether you boil it or you fry it or you poach it, whatever the case is, when you've cooked that egg, it's not going to go back to being a raw egg. It's changed permanently. Another really cool example over at the top right is rusting. Have you ever left a piece of metal outside, maybe a bicycle or a shovel or something, and when you come back you notice brown spots on the metal? That's a process called rusting. The exposure to oxygen and moisture causes the metal to rust. You can't undo that. Maybe you can rub off some of the brown spots, but actually when you've rubbed off those brown spots, you've rubbed off a piece of the metal that has rusted. So that metal has turned to rust. You can't get it to go back to that silvery looking metal. That shovel in the top is a perfect example. It was once a perfect shovel and now it's full of holes because the metal has rusted. There's no going back. Finally, at the end, I believe that's an example of like cement. I think it says mortar. So when you've mixed up the sand and the cement mixture, you can't separate them again. Once they've come together like that, there is no separating. I know when we said in class that many mixtures can be reversed, you can separate the mixtures. Some mixtures cannot be reversed. Cake batter is another example of that. When you mix the eggs and the sugar and the flour all together, you can't pull them back apart. So those are irreversible changes. So take a look at these. What would happen to these objects if you heated them? Which of the changes would be reversible and which would be irreversible? Take a moment to think about it. Which of them, when you heat it up, would change but then could be changed back when you cool it down? Which of them, when you heat it up, could not be changed back to what it originally was? Well, I'm going to go through this one with you, and the next poster I show you, you're going to have to figure it out yourself. So in this example, we have an egg. We've spoken about this before. Once you cook an egg, it's changed permanently. So that is a chemical change. It is irreversible. Chocolate, on the other hand, if you heat it up, it melts, but if you stick it in the fridge or cool it back down, it goes back to being solid chocolate. So that's just a change in state. That is reversible. It can go back to what it was before. Same thing with an ice cube. We spoke about that one too. You can melt it, but you can also freeze it. So it can change states easily and go back to what it was before. A candle. Don't be tricked by the burning there. If you've used a candle before, you might notice that the wax of the candle just melts and pools at the bottom. Well, the wax is still wax. When it cools down, it hardens again. So in that case, even though there is burning going on, the wax itself has not changed. All it has done is melted. Try this at home with your parents if you want. Light a candle and you'll notice the wax start to drip down and it's going to pool at the bottom. Some candles even have features where you can melt it back into its original shape. So that is just a change of shape and state, but it can go back to being a solid candle. A potato, on the other hand. Can you unbake a potato? Can you unfry a potato? No, that's an irreversible change. Butter, we looked at that one before too. You can melt it and then you can cool it back down and get it to how it was before. So that change is reversible. Remember, reversible changes are physical. Irreversible changes are chemical. All right, so this is the point now where you're going to need to head up your book. Put today's date. Our topic is going to be changes in materials. You can go back to the beginning of this video if you want to see that. Our learning intention is to be able to tell the difference between physical changes and chemical changes. Once you have that written down in your book, you can pause this if you need to. I want you to create a T-chart. On one side of the T-chart, you're going to have chemical changes or irreversible changes. On the other side of the T-chart, you're going to have reversible changes or physical changes. Underneath, you are going to sort out all these little cards that you are currently seeing on your screen. Breaking a window, baking a cake, slicing bread, and so on. You're going to have to decide which type of change these are. So you might draw the picture with it, or you could just write the words. It's up to you. If it was me, I would draw the picture. We have time. So breaking a window. When you break a window, Sure, you can't really get the window back to how it was before, but has the glass of the window changed? It's still glass, isn't it? I could technically tape all those pieces back together, couldn't I? And it would still look the same or very similar. There's no chemical change going on here. This is just a physical change. It's changed shape. So this one, the first one, breaking a window, would go under physical or reversible changes. You're going to sort the rest on your own. When you're done, I want you to take a picture of your T-chart and send it to me. Before we sign out today, I have a little bonus activity for you. Miss Watler would like to get pictures of students doing various bits of work at home. I want to see you guys doing some science work at home. What I want you to do is go into the kitchen with your parents and create one reversible change. That's a physical change. Maybe you'll make some ice or melt some chocolate. And I want a picture of you doing a chemical change or an irreversible change. Maybe you'll help your parents cook dinner. If they're cooking something like chicken, you can't uncook the chicken. So that is, of course, a chemical change. Send me those pictures and it could become a part of our school's Facebook page and our YouTube channel. All right, you guys, stay safe and I'll see you soon. Bye.